In this video, we are going to talk about regeneration gas turbine cycle. Many researchers have focused on improving thermal efficiency in recent years. Increasing thermal efficiency lowers operating costs by using less fuel and reducing the amount of flue gases, COS and NOS, released into the environment. As a result, extensive research efforts have been made to improve the thermal efficiency of steam and gas turbine cycles, thermal power production. A variety of techniques can be used to improve the thermal efficiency of the cycles. Reheating is a technique used to increase the thermal efficiency of the steam and gas turbine cycles. Thermal efficiency may improve if a combined cycle utilizing a gas turbine with regeneration is used. The regenerative gas turbine cycle takes a similar approach, and it also conducted a parametric study similar to the one used now. The operational conditions in this paper differ from those in the previous strategy. So that's all for me. Thank you.
Working principle. Regeneration is the recycle process used in gas turbine to heat the air after compression by using the heat energy lost in the turbine exhaust gases. Utilizing the high heat energy that the hot gases released by the turbine have allowed us to reduce the amount of heat energy lost. One of the heat exchangers used in this method, the regenerator is installed. It aids in transferring heat from exhaust gases to air before it enters the combustion chamber after compression. The benefit of using this method is that less fuel is needed because less heat is needed to heat the air in the combustion chamber. When the air is compressed to a high temperature and pressure using air from the atmosphere, and the regenerator adds heat from turbine exhaust gases to compressed air after the compressor. In the combustion chamber, where fuel is directly mixed with the high pressure, preheated air, the air from the regenerator continues to flow. The regenerator emits hot, high pressure gases, which are then directed toward the turbine. When these hot, high pressure gases are struck by the turbine, they expand and power is generated by the turbine. The compressor and turbine are connected in order for the power generated by turbine to also to use to power the compressor. After pass through the turbine, these hot gases pass through line regenerator where their heat energy is transferred to the air to the fresh compressed air. For diagram, 122 isentropic compression, 223 constant pressure heat addition, 324 constant pressure heat addition, 425 isentropic expansion, and 5 back to 1 constant pressure heat rejection.
I will present for this diagram. For, for the first point is pressure and temperature are increased. When pressure and temperature are increased, the air density decrease and mass flow and pressure capability decrease too. For the result, reduction in capacity is often addressed by operating additional compressors, thus increasing energy consumption. For the second point is constant pressure. At constant pressure, an isobaric process occurs. The force exerted is constant since the pressure is constant. Heat should be delivered into the system at a specific pace if gas is to expand at certain pressure of an isobaric expansion. For the last point is pressure and produce work. The effect of pressure and produce work is increased ambient temperature lowers than the density of the inlet air, thus reducing the mass flow through the turbine and therefore reduce the power output. Thank you.
Summary: in the generative gas turbine cycle, where heat recovery is performed by the air or steam mixture obtained through contact between water and part or all of the compressed air. The compressed air is compressed by a compressor to compress the gas using air or air-based gas as a medium support work gas combination improvement consisting of a mixture of air or steam and liquid fresh cool water combined by contact between compressed air and heat water use a heat recovery medium. Chilled water is used as a heat recovery medium not only for turbine exhaust gas heat recovery but also for interface cooling or pre-cooling of compressed air for contact operation. Supply water corresponding to the amount of water that contact the compressed air and is loaded by evaporation to liquid phase water for contact heat recovery as is after being used as a heat recovery medium.
In conclusion, the parametric study showed that the compression ratio and inlet air temperature had a major effect on the thermal efficiency of a simple and generative gas turbine cycles. Adding generation to simple gas turbine cycle result in the increase of thermal efficiency of the cycle, increasing of compression ratio result in the increase of the thermal efficiency of simple and generative gas turbine cycle. That's all from me. Thank you.